how many times did every user stream every track? Most of it is going to be 0, because there's so many weird tracks. But like, essentially what you're going to get is like a super big matrix with as many rows as you have users, and as many columns as you have items. Okay, so something like this. 10 million rows, 10 million items. So it's a big one. So one thing that we can kind of do, like one conceptual way to look at it is that if we can try to predict what people are going to listen to in the future, that's probably a pretty good recommendation. So this is called unsupervised learning. Basically trying to forecast things. It's an approximation. It's not exactly what goes on, but it's a good approach. It's a good way to approach a problem. So so how do we do this? We have a super big matrix. We want to find patterns. How do we do this? Kind of like a stupid, naive way to do it is we could look at columns. We can try to calculate some kind of correlation coefficient. Basically, you can define correlation coefficients in many ways, but one way to do it is like Pearson Pearson correlation. I mean, there's other ways to do it. I don't want to go into the details, but actually, this is what people used to do in the 90s and are still doing, and it works pretty well. But it has a couple of disadvantages. It doesn't scale well, and it tends to overfit. It tends to not handle noise very well. So the question is, can we do better? And just to give you an idea why this isn't scale, if we start with this matrix, essentially we want to compare every pair of columns, and that turns out to be very computationally inefficient. So we can do other things. You can do like some kind of probabilistic way. You can hash this. I'm not going to go into details, but people do this. But I'm going to talk about what we do. So what we do is called matrix factorization. You should like totally feel free to like interrupt me, by the way, if you have any questions. I realize I'm going through this very quickly. So let me know if you have any questions. But essentially, matrix factorization as a method was kind of first explored back in the 90s when people looked at document classification and natural language processing. And back then, it was all about like you have documents, those documents have words, and we want to find like what are like similar documents, what are like words that mean the same thing, and like how can you classify documents? Is this about news? Is this about something else? So people spent a lot of time doing that back in the 90s. So essentially, like, if you think about it, you can replace words with tracks and documents with users, and you kind of get the same problem as Spotify has. So essentially, you can just like take all these methods and scale it up to use Hadoop, and you get pretty good recommendations. So what the hell is matrix factorization? The idea is we want to take this super big matrix and we want to write it as a product of two small matrices. One is a user matrix, and the other one is a item matrix. And the cool thing about this is you essentially get, this is only like 2 dimensions, like 2 latent factors, but essentially you can choose how many factors you want. Cool thing about it, you get like a really small like vector for each item, and this vector is like kind of a fingerprint that is a compact representation of what is this track about, or what is this user about. So you get these small vectors, and you can take the cosine between 2 tracks and essentially get a similarity metric like really quickly. And these vectors typically only have like 40 numbers, so it's really cool. Like you can just take 2 vectors and just like in a matter of like a couple of arithmetic operations, you can figure out are these tracks similar or not. And there's tons of different methods. One kind of like the first method that was invented is called PLSI, invented by a guy called Thomas Hoffman, and it's essentially a probabilistic method where we try to predict like what are probabilities of future events. Try to write it as a product. I'm not going to go into details. A whole bunch of stuff. How do you solve it? You have to write a bunch of Hadoop jobs. Cool thing is it works pretty well. And just to give you an idea of what's actually going on, what you start with is you just assign like tracks random vectors, and you run this many steps, and it kind of converges into like some kind of world where you get some kind of segmentation of different tracks. So in this graph, like every point is a track, and I colored it, except this projector seems to suck, so it's hard to tell what track is what genre. But I'm going to show you some more of this stuff. So in this case, we only did two factors, and you get like a two-dimensional representation, because it's hard to show like a 40-dimensional representation in a projector. Here's another picture that I'm very proud of. So we start these guys down here. We assign them random vectors. In this case, I do this for artists instead. And then we just run this many iteration, and they kind of like diverge essentially into like different corners. You can see that you get like metal in the upper left corner. You get boy bands in the middle. You get hip hop over there. This is Florence and the Machine, Lana Del Rey. So like female singing-songwriters. Again, this is only like 2 dimensions. You can do this like for 40 dimensions. You're gonna get a much better separation in like different dimensions. So yeah, and it's the nice thing again. I probably said it like 95 times already, but you get vectors, so you can just take these vectors and immediately say like, oh, the cosine is really high, so they're super similar. And if you don't believe me, I actually put together some numerical examples here. And as expected, cosine of 2-pack with 2-pack is 1.0, because 2-pack is 2-pack, so it's by definition of cosine. But you can also see that kind of makes sense what you expect. Hip hop has pretty high similarity. If you try to go between different genres, you get lower similarity. Just to prove to you that I'm not just like making this up, I also embedded like a couple of thousand tracks here, and I color coded them by genre. So the genres, we do have some metadata about like what tracks are what genre. So ran this method, and you get like an embedding in the plane. And I mean, yeah, it should be obvious that there's some kind of segmentation going on here. You tend to get like classical tracks down here. You tend to get metal along the y-axis, and everything else gets segmented pretty cool. So yeah, so how do we implement this? It's all about building Hadoop jobs and just scale it up. This is our second or third Hadoop cluster. We have a much bigger one now, almost twice as big. Just kidding, it's 100 times bigger. Yeah, so I talked a lot about like the maths. Just wanted to mention that we are rolling out a lot of like new cool features. We're planning to deploy this really cool Discover page pretty soon, which features a bunch of like personalized recommendations, like you listen to Radiohead, check out views. Barack Obama created a campaign playlist. I don't know if we can do like political profiling of people, but maybe if I spend some more time coming up with good algorithms, we might be able to. Some kind of YouTube style recommendations going on over here, where I try to show some similar stuff to what you're playing. What else? Some kind of recommendations here. You listen to some things, so check out some other artists. Yeah, some concert going on in your town. You should go there, and a new release. So you should check it out because you already listened to that artist a lot before. And we're hiring, mainly in New York, but also in San Francisco. I mean, for machine learning music discovery. Any questions? All right. Thank you.
I have a question.
Okay, go ahead.
Did you use any open source software for doing the matrix factorization?
The question is, do we use any open source software? The answer is no. I know there's a couple out there. There's like Mahout. I've looked at it. I don't think it scales that well still, but I don't know, maybe in a year or two, we'll see. And also, I started building this before Mahout existed.
I have another question. How did you evaluate? Did you use multiple algorithms or pick which one's the best one?
So the question is, how the hell do we know that these recommendations actually work? And then the answer is, you just need to do a lot of A/B testing. You can do some offline evaluation. You can look at the data. You can also define some metrics and say like, oh, how well did we predict what the user is going to do, or like, how well did we predict whether the user is going to skip something in the radio station? But at the end of the day, all you can do is like A/B test. That's the only way that really counts. More questions? All right, thank you.